Now we are going to understand the amphoteric nature of the water. You know what is amphoteric oxide means?
Neither acidic nor basic.
Or else we can say those substances they react with acid as well as base are called as amphoteric oxide. Okay, those non-metallic oxide they react with acid as well as base are called as amphoteric oxide. Understood? We can't say whether they are like not acidic not base like this. Okay, we would say the ability to react or act with acid as well as base are called as amphoteric oxide or amphoteric substance. Understood?
Yes, sir.
Yes. Okay, so their amphoteric nature is due to ability to form the bond, okay, with acids as well as base, because when these substances dissolve in water like acid as well as base, they undergo dissociation to form ions, and those ions then reacts with water, okay, to form, in case of like suppose we are taking let example we had to go through example first. Suppose here we have a bit of water, okay, and when ammonia reacts with water, so what generally happens during the reaction, that water molecules undergoes dissociation. Okay, so water will dissociate, forms beta H positive ion and OH negative ion. Is it or not? Here we have ammonia NH3. Okay, so see, in ammonia on nitrogen, what is the atomic number on nitrogen? It is 7. Is it?
Yes, sir.
So its electronic configuration is what? It is 2 and 5 beta. 2 and 5. So I'm just writing this outermost electron around the nitrogen, means they are the electron of outermost shell. Is it? So here nitrogen has bonded with 3 hydrogen. So one hydrogen will form bond with that electron, another will be with that one, and another hydrogen will be that one. So see here we have NH3. In this state, 2 lone pair of electron are present in outermost shell. Is it or not? They are called as bond pair of electron. Bond pair of electron, and these electrons are called as lone pair of electron. Lone pair of electron. Understood that? Lone pair and bond pair?
Yes, sir. I
Yes.
understood.
Yeah. So when in presence of ammonia, okay, that water molecule undergoes dissociation to form H positive ion and OH negative ion. See, H positive ion, that means hydrogen is electron deficient species. It is electron deficient. It is electron deficient chemical species. Is it or not?
True.
Yes. So that hydrogen will going to approach nitrogen for electron, because nitrogen had 2 lone pair of electron. So nitrogen will donate 1 electron to hydrogen atom. Okay. So hydrogens then see, nitrogen is losing 1 electron, and that hydrogen, that H positive ion, going to accept that electron. So now again hydrogen will form bond over here. In that case, nitrogen acquires positive charge. Understood? So that's why we have here it is NH4 ion. Okay, NH4 ion. So that NH4 ion then reacts with OH to form NH4OH, ammonium hydroxide, NH4OH. But again, when temperature is being constant, then that reaction proceeds in backward direction. This is forward direction, and this is the reaction in backward direction. Okay, so that undergoes dissociation and again association in backward direction. So equilibrium start here. So this is the sign for equilibrium beta. This is the sign for equilibrium. So as we can see here, that hydrogen positive ion approaches ammonia. So we can say ammonia is accepting H positive ion, means ammonia is acting as a base here. Okay, so those chemical species they accept H positive ion are called as base, and those chemical species which loses H positive ion are called as acids. Is it or not? Is it? Keep replying.
Yes.
Yes. So we know, suppose we have HCl, and when we will dissolve in water, so it will form Cl negative ion plus H positive ion. So HCl is losing hydrogen. That's why it is acting as an acid. But if we will reaction will carried out in backward direction also like this, in backward direction. That means that chlorine is going to accept that electron H positive ion. So here chlorine is acting as a base. So on that base, on what basis we have decided it is acid and base? On the basis of losing of hydrogen or accepting of hydrogen positive ion. Is it?
Yes,
Yes.
sir.
So on that basis, that ammonia is acting as a base. That means that water is acting as a acid here. Okay. And here that ammonium H positive ion, okay, and here we have OH negative ion. It is nothing but this ammonium hydroxide, and that ammonium hydroxide again going to dissociate to form OH negative ion and NH4 positive ion. So that ammonium hydroxide is going to lose H positive ion. That's why it is acting as a base. Okay, so here again we have like a pair of Bronsted acid and base pair. Okay, so here we can see, we can like conclude that here that water is acting as an acid, and in this reaction it is acting as a base. Okay, that's why we can say that acid acting like water molecule acting as a acid as well as like a base. That's why it is going to be amphoteric in nature. Okay, it reacts with sulfur dioxide like hydrogen sulfide to form H3O positive. That means here that HC, second reaction, I'm going to explain with the help of red ink here. See, here that water molecule is not going to dissociate. That hydrogen sulfide is going to dissociate. So hydrogen sulfide will undergo dissociation to form H positive ion and SH negative ion. So that water molecule going to accept that H positive ion. Okay, so here it is acting as a base, and here water molecule was losing H positive ion, so here it was acting as an acid. Okay, so water acting as an acid as well as base, that's why it is amphoteric substance. Any doubt beta here?
No doubt, sir. Understood.
Understood now. So just do remember, whenever water molecule donates H positive ion, it is acting as a acid, and when it accepts H positive ion, then it is acting as a base. So it depends on the available condition on which water is going to act as an acid or base. It shows that water is an amphoteric substance. Understood? So
Yes, sir.
yes, you can explain that with the help of reaction of water with ammonia and a reaction of water with hydrogen sulfide. So if you want to take a screenshot, you can. Otherwise, we'll leave the page and we'll move further. Understood, Bida? Done. Taken screenshot.
I wrote it down, sir.
Oh, now we had a short answer type questions. Okay. Discuss the position of hydrogen in the periodic table on the basis of its electronic configuration. So we know that hydrogen have only one electron. So its electronic configuration will be one only. Is it? So that one represents the first group. First group. And that only one shell is present here. Only one shell we have, is it? So that number of cell represents the period number. Okay, so we have in outermost cell one cell, that means it is present in first group, and number of cells is only one we have over here. That's why it is present in first period. First period. Okay, so the position of hydrogen atom in modern periodic table is first group and first period. Understood, beta?
Yes, sir.
Yes. So you can write here the position of hydrogen atom in modern periodic table on the basis of its electronic configuration is, okay, from here is first group and in first period. That's all, nothing more than that. Done?
1 second. Yes, sir, done.
Okay. So reason for position of hydrogen in 7th A. Okay. So now see, hydrogen is the element which is showing properties of first group element, as well as 17th group element. I'll explain how. See, first group element we have like hydrogen first, then we have lithium, then we have sodium, then we have sodium potassium, then we have cesium and francium. See, on the basis of their first group, they have electronic configuration in which all the elements of the same group are present in first group, and they shows same outer electronic configuration. That means all they have equal number of electron in their outermost shell. Okay.
Okay, sir.
Okay. Okay. So, and hydrogen will also have one electron in its outermost shell. That's why all this element of first group shows one valency. Valency is 1. Okay. Likewise, element of 17 also, they have 7 electron in their outermost shell. That means they require one more electron in order to acquire stability. Is it? That's why 17 group element also have valency 1. Understood? So both have valency 1. That's why hydrogen can be placed along with first group or 17 group. If we will compare hydrogen with element of 17 group, then hydrogen react easily with the element of 17 group. Like when fluorine, see, in 17 group we have first element fluorine, then we have chlorine, then we have bromine, then we have iodine, and then we have astatine. Fluorine, chlorine, bromine, iodine, and astatine. So all they react with hydrogen to form like their hydride. Okay, like fluorine will form like hydrogen fluoride, so they form iodide instead, we can say. Chlorine will form hydrogen chloride, bromine will form hydrogen bromide, iodine will form hydrogen iodide, etc. Okay, so again it reacts with element of first group as well as 17 group. That's why hydrogen shows similar property as, means it behaves like first group element as well as 17 group element, and 17 group elements are called as beta halogens. Okay, and all these elements are called as halogen family. Okay, all these element along with, okay, their group are called as halogen family. And what is mean by halogen? They are salt forming element. Salt forming elements. Okay, so all these are the reason by which we can conclude that hydrogen behaves like first group element as well as 17 group element. Okay.
Yes, sir.
Yes. See here, as you can see, sodium, not here. This chlorine is from 17th group, and here we have hydrogen. Then here we have hydrogen, sodium also. Sodium is from first group. Okay, so they behave like, or we can say they show similar properties as first group element as well as 17th group element. Okay, means like alkali metals as well as with the similar to the halogens also. Okay, here we have alkali metals as well as they behaves like halogen, means element of group 17. So this is one of the like drawback of modern periodic table, that hydrogen still do not have fixed position in periodic table, whether it is going to place with first group element like alkali metals or with halogens, means 17 group. It has not been confirmed yet. That's why it is one of the like drawback of modern periodic table. Okay.
Okay, sir.
So they show similar property to alkali metals as well as like halogens. Okay. Now we are going to discuss about heavy water. What is mean by heavy water? Yes.
I don't know, sir.
See, heavy water means when heavy metals and metallic salt are present in dissolved form or suspended form in water, that water is called as beta heavy water. Okay, that water is called as heavy water.
Can you repeat
So
the definition, sir?
when heavy metals and their salt or oxides are present in dissolved form or in suspended form in water, then that water is called as heavy water.
Okay, sir.
Yeah. So it can be prepared by exhaustive electrolysis of water on as a byproduct of some fertilizers industries. Okay, so that heavy water can be prepared by electrolysis process. It is used for the proportion of the deuterium compound. For example, as you can see here, we have calcium carbide, okay, and deuterium oxide. When they react, they form calcium, carbon and deuterium's compound as well as like the byproduct. So as we can see here, that deuterium and calcium are nothing but the heavy metals, and they can dissolve in water and may present in suspended form in water. That water is called as then heavy water. So most of the time what happens generally, the water that we are getting from the, what we can say, the tube well. Okay, so we know that tube well is formed by the making a big hole, or we can say the bore well on the deepest way, like 200, 250, sometimes 300 feet underground. Okay, so in that particular zone, when stream of water are being flowing underground, they contain dissolved salt and heavy metals in them. Okay, so that heavy metals, and they may be present in salt form or in suspended form in water. That water is again called as beta heavy water. Okay.
Oh, yes, sir.
Yes. So such heavy water can be prepared in laboratory by adding like carbides of calcium or oxides of deuterium in it. Okay, and which can be used for different purpose. Okay, like here we have, it is used as a moderate in nuclear reaction. So we know in nuclear reaction we are using uranium metal. You know uranium atomic number is 92 and
Yeah.
its atomic mass is 235. When we are firing neutron in nucleus of uranium, okay, it split into two parts, or it first convert into uranium 236. 92 will be the atomic number. Okay, so that 236 uranium's isotope is very unstable, and it split into two parts and it forms beta. First is called barium and other is called krypton, along with three neutrons again released during the reaction. And these three neutrons again firing on three isotopes of uranium-235 and the reaction continues. Okay, so this is the chain reaction. In order to control such chain reaction, we are using moderate, okay, in order to slow down the chain reaction, and where we are using the heavy water. Okay, okay, beta.
Yes, sir.
Yes. Name the isotopes of hydrogen. So we have beta three isotopes of hydrogen. Okay, so I am writing here. See, one hydrogen have atomic number 1, other also have atomic number 1, and third one also have atomic number 1. But the atomic mass of first hydrogen is 1, only proton is present here. Here we have 2 atomic number and here we have 3 atomic number. So first one is called as beta protium, that one. Because only proton is present in its nucleus, so it is called as protium. Protium also. Second one is called as beta deuterium. Okay, because its atomic mass is 2, that's why it is called as deuterium. And third isotope having atomic mass 3 is called as tritium. Okay, it is called as beta tritium. And in protium, no neutrons are present, so neutrons are not present here. Okay, I am writing neutron not. Oh, wait a second, like not like this, like this. No neutron. Here we have 1 neutron and here we have 2 neutron. So 2 neutron plus 1 proton equals to 3 atomic mass. Here 1 neutron plus 1 proton equals to 2 atomic mass. And here only 1 proton is present. That's why it is having atomic mass 1. Understood? Keep replying, beta.
Understood, sir.
Okay. So these isotopes differ from each other in the presence of neutrons only. So in first we do not have any neutron. In second we have 1 neutron, and in third we have 2 neutron. Only this is the difference between all these 3 isotopes. Okay. So here protium have no neutron, deuterium have 1 neutron, and tritium have 2 neutron in their nucleus along with proton. Okay.
Okay, sir.
Yes, and very important, out of these 3 isotopes, only tritium is radioactive in nature because it emits radiation. Okay, it emits low energy of beta particles. Okay, and which is relatively ratio of the masses of isotopes are, here we have, it is for protium, it is for deuterium, and it is for tritium. Okay, if we will compare their atomic mass in like simple whole ratio form, so we can have like 1:2:3. Okay, here 1:2:3. Understood? Yes, so take a screenshot again.
I wrote it, sir, already.
Okay, so now we are going to discuss about the principle and method of softening of hard water by synthetic and ion exchange resins. Okay.